In this problem, we're asked to solve using the elimination method. Let's take a moment to read the word problem. We are told that whole milk is 3.8% fat, skim milk is 1% fat, and the company would like to make 50 gallons of 2% milk. We're asked how much whole milk and how much skim milk should they use. So when I have a scenario here with the percentages, I have a strategy for making my equations to represent what is going on in this scenario. It is not an exponential scenario because the percentages do not represent growth. The percentages represent a portion of something. So in this scenario, I have in my head this concept that I would like to have an items equation and a value or percent equation. So what are the items that I'm working with? Well, when I look at the question that they asked me, I see that my two items are whole milk and skim milk. And so in my items equation, I'm going to make whole milk X, I'm going to make skim milk Y. These are the items I need to figure out. So I'm going to be mixing together some whole milk plus some skim milk in hopes of creating 50 gallons. So this is how much they want to make. So that's that word make there. So when I mix these two, my two items get mixed together for 50 gallons total. My next equation is going to bring in values. So when I think about the value, well, the thing that is of value here is the amount of fat. That's the differentiator between the whole milk and the skim milk. So I have this goal of creating 2% milk, which has 2% fat. And so how much is the whole milk contributing to that goal? Well, it's contributing 3.8%. So that is its value or its contribution. So I know to change percents to a decimal. So 3.8 divided by 100 gives me 0.038. And I know mathematically we have to take the percent of something, which is multiply. So this much per or times the number of gallons of whole milk. And so that whole milk is represented by my X. So 3.8% of the whole milk is a times X. Need to do a similar thing for the fat that is contributed by the skim milk. So I take 1 and divide by 100 on my calculator. I get 0.01, and that has to be multiplied by the Y because it's the percentage of fat for that skim milk, which is Y. And then what do I end up with? Well, I want to end up with 50 gallons, and I want it to be 2% fat. So I have to put my percent as a decimal, 0.02, of what? Of that total 50 gallons. So as I compare my two equations, my items equations is just an addition. I asked what two things am I mixing. I made one variable, one the other variable, and added them up to a total. In my value or percent equation, you'll notice that every single piece, the X, the Y, and the total, are multiplied by the percentage of fat because that's what they're contributing. Now, I have my two equations, and I want to use the elimination method. So in the elimination method, we have this idea that we're going to strategically multiply so that one variable will add to 0. So when I look at my two equations that are here in front of me, and I think about what should I strategically multiply by, the thing that comes to mind is that if my y value, right here, had as its coefficient, if this was negative 0.01y, then I could add it to the positive 0.01y, and they would be eliminated. Right? So if I'm going to get this coefficient in the first equation to be negative 0.01, I'm going to have to take that entire equation and multiply it by negative 0.01. So I'll try to use some color here to help you see exactly what's going on. So I strategically picked negative 0.01, and I need to multiply that times the entire equation for the first equation so that I'm keeping both sides of my equation equal because I'm doing the same thing on both sides. And so I'm going to put my equation in here, x plus y equals 50. And then I have to distribute. So this will give me negative 0.01x. Distributing minus or plus a negative 0.01y, and distributing, so multiplying over here as well, and I get negative 0.5. Now, I'm going to bring my second equation in, and I'm going to exactly line it up. So in my second equation, I have 0.038x plus 0.01y equals, and I'm going to do the math here. So right here, I have this equation, or this little bit of math. So I'm doing that on my calculator. And when I do that on my calculator, 0.02 times 50, I get 1. So I'm going to write that down here as a 1. Now what I'm going to do is I'm going to put an equal sign below them. I'm going to put an addition sign out front. And the reason why I can do this is because the equation, both sides of it are equal, so I'm adding the same amount, even though it looks totally different to each side of the equation. I strategically multiplied so that my y values are now canceled out. And so I add together on the x values here, and I get 0.028x equals, and I add together on the constant 0.5. And so then I will divide on both sides by the 0.028. That will cancel, and I have my x value, and I got 17.86 gallons. So I look back, what was I solving for? Well, my x stood for my whole milk, so that's gallons of whole milk. I still need my y because it asked me how much whole milk and how much skim milk. So in order to get my y value, I want to go back and use substitution with one equation. I'm going to use the first equation because it was the simpler equation, but either equation would work. So instead of x, I'm going to write the value it is, so 17.86 plus y equals 50. And then to solve this for y, I will subtract 17.86 from both sides. And that will give me my answer that y is equal to 32.14. And that'll be gallons, and that will be skim milk. So that is an example of how to use the elimination method for solving a system of equations.